So in this video, we're going to take a look at how we can interact with ClimateSERV data using the API. So that's the application programming interface. And what that is it allows us to use programming to implement the whole functionality that we saw in our last video with the user interface in a programming environment. So the API is language agnostic, which means that you can use any programming language you want to interact with the data. But in this case, Servier has already written a Python package called ClimateSERVpy. So that's what we're going to be using to interact with the API today. But if you'd like to write your own package for a different language, you certainly can do that, and there are resources on ClimateSERV's website to help you do so. So our first step is going to be to work with this notebook here, which is linked in the course materials. And this is going to provide you with an introduction into working with ClimateSERVpy. So this video is going to cover tabular data, which we'll use to get a time series of our data, similar to what we did with the statistical query panel in the user interface. But you can also, of course, request and visualize raster data, geospatial data, with the API as well. But this video is just going to cover tabular data. So I've got the Google Collaboratory notebook pulled up here. And so we're just going to walk through each of these steps. Your first step when working with this notebook is going to be to click File up at the top and then click Save a Copy in Drive. And that's going to make it so that you can edit these cells later on instead of changing the notebook itself. So first I'll click File, Save a Copy in Drive, and that's going to open up my own version, and then I can just close out of the original and we'll work through the notebook in this copy here. So in part one, we're just going to install the ClimateSERVpy package, and we're also going to mount our Google Drive, and that's going to allow us to write data from ClimateSERV directly into our Google Drive. So first I'm going to run install ClimateSERV using this pip function here. And you can install this onto your local computer as well, but in this case we're using the exclamation mark in Google Colab to install it locally here. Or excuse me, not locally, but on this instance of Google Colab. We can see that it's running, and it'll take about 15 seconds to finish. And then after that's installed, we see a green check mark there, so we know that it has installed. We're going to import the ClimateSERV API package into this notebook, and then we're also going to import some other packages which will allow us to plot the data and collect the data within our Google Drive. And if you're not familiar with the terminology associated with Google Colab, these are called cells, and so we have code cells and text cells here. And all of the instructions that I'm going to go through in this video are written out in these text cells, or what's called markdown cells here, if you want to just refer to the notebook individually. So now that we've imported ClimateSERV and those other packages, our next step is going to be to mount Google Drive, which will allow us to access Google Drive files in this notebook. So after I run that cell, it's going to ask me to connect to Google Drive. And I'll click that and click the Google account that I want to work with. Click continue, and then this will take, again, about 15 seconds to run. But when that's finished, we'll be in our Google Drive, but we have to navigate to the specific folder that we want to use when we're writing and requesting our data from ClimateSERV. So we can see that our drive is mounted. Our next step is going to be to use this choose directory function, or CD, to navigate to a specific folder within our drive. So this command will bring you to the My Drive page. So if I open up my Google Drive, now our current working directory is just going to be whatever you see when you open up Google Drive in your browser. But we don't want to request our data to our drive as a whole. It will get a little bit hard to organize. So in this case, we're going to use this mkdir method, which stands for make directory, or which you can think of just as a folder, to make a folder called ClimateSERV_exports. So I'm going to run that, and then if we return to our Google Drive, we can see that before we didn't have a folder called ClimateSERV exports, but there it just popped up. So that's what the make directory method does. If we open that folder, we'll see it's empty right now, but we're going to change that in this video and write some data from ClimateSERV to this folder. And so we can use the pwd method, which stands for print working directory. First I need to run this cell to actually choose the ClimateSERV exports directory that we just created. And now when I run pwd, instead of just having our main drive be the working directory, now it's going to say ClimateSERV exports. And so if you're not familiar with Python or Google Colaboratory, your working directory is where Python is going to save files, write files, things of that nature. So now when we request data from ClimateSERV, it's going to show up in this ClimateSERV exports folder, and that's our working directory here. So we are all set to go. We can also run this ls command, which stands for listing, and this will list all of the files in your working directory. Of course, our current working directory is blank, as we can see here in Google Drive, so this is going to return nothing. But after we request data from ClimateSERV, we're going to see that that will change. So that's part one, just getting up and running with Google Colab, Google Drive, and importing the ClimateSERVpy package. So now in part two, what we're going to do is we're actually going to request data from ClimateSERV. So I've included here a code block that you can run as is. So we're specifying these different parameters, and then in the next cell, what we're actually doing is requesting the data from ClimateSERV. So we're going to lay more detail as to the what these different parameters mean later on, but right now let's just run the code and see what we get. But I will cover each of these parameters in detail later on in this video. But as you can see, we're specifying a geometry, what data set we want from ClimateSERV, an operation type, which we'll get into more later, a start and an end date, and then an out file that we want to write this data to. And as you can see here, we're requesting a CSV file, so this is going to be a time series of our data. It's going to be tabular data, similar to what we saw in the statistical query panel in the user interface in our previous video. So I will run this cell, and then I will use the ClimateSERV.API.request_data method to request data for this time period, for this region of interest, and write it to this file. So we're taking all of the parameters that we specified up here and feeding them as arguments into this request_data method. So I'll click run, and when I click run, we can see that ClimateSERV has recognized that a new job has submitted to the server, and it will keep you updated with the progress in units of percent as it works through this request. As we can see, this one didn't take very long. It's already completed. And as you can see, it says it is attempting to write CSV data to that out file name that we gave up here. And it says that it has succeeded, but we want to double check and see if it really has succeeded by running that ls command, which again stands for listing. And we can see that indeed we do have a CSV file written to that folder. If we check in Google Drive, we can see that the same thing has occurred. This CSV file has been written. So I'm going to go ahead and open up this CSV file just to show you what it looks like. So as you can see, it has the job ID that ClimateSERV has associated with your data request, and then it has a column for the date of the acquisition, as well as the data itself. So to understand this data, this is where you're going to really want to work with the ClimateSERV dataset encyclopedia that we encountered in Unit 1 to make sense of these values. So in this case, you can see that I requested the emerge precipitation data. So going to that dataset in ClimateSERV, or excuse me, in the dataset encyclopedia, we can see that the units of this dataset are in tenths of a millimeter. So that is the units that we're getting here. So what we want to do now is take this tabular data and visualize it in a plot. So I've written some code here that allows you to do that using the np.loadText method. Of course, you can use any method you want to take this CSV file and turn it into a nice visualization. So here we can see a plot of our data. So we have on the x-axis the days since September 1st, 2015. Oops, I made an error there. This is supposed to say 2015. And on the dependent axis rather, we have our precipitation in units of tenths of a millimeter. So that's a really simple example of how to take a CSV file that you obtain from ClimateSERV and turn it into a visualization. So in the next step of this notebook, you're going to go ahead and edit this text cell and try it for yourself. So at this point, I'm going to explain these parameters in more detail. So at the bottom of this notebook, in the appendix, you can see all of the different arguments for the API request data method, as well as what you can specify those arguments to be equal to. So you can see for each heading here is going to represent one of those different arguments. And within each of those arguments, you can see that there's specific strings that you have to give to ClimateSERV in order for this request data method to work. So you can see each of these data sets within ClimateSERV has a specific data set string associated with them. Likewise, there's different operation types that we can do. In that first case, since we were working with tabular data, we used average as our operation type, but we'll see in the next video that if we want to use raster data, we can specify the download string as our operation type, and that will allow us to download the raw raster data from ClimateSERV. So when you're working in part 4 here and trying this out for yourself, you can just refer to the appendix or to the ClimateSERV documentation, which is linked here, to determine what strings you need to give to this request data method. And all I mean when I say strings is just text enclosed within quotation marks. And that's going to be how we usually feed our arguments to this method. And what I mean when I say arguments is just each of these variables within this method or function that we see here. So now I'm going to show you what this looks like in a live coding format. So I'm going to pick a region of interest, I'm going to pick a data set of interest, and specify all of those other arguments here. And when I'm doing that, it's much easier for me to work with the ClimateSERV dataset encyclopedia. So let's say that I wanted to use the ClimateSERV API to download forecasted data. In the initial example, we worked with historical data, but of course ClimateSERV offers forecasted data as well. So I would scroll down. Using the table of contents here, I can see that we have historical data as well as model forecasts and hindcasts. So I'll scroll down to chapter 2 here in order to access those. So we can see that we have the UCSB CHIRPS GEFS data, and we have the NMME forecast data. In this case, I'm going to request the NMME data, and we can see if I scroll down to subsets, I can see that there's 2 different subsets of this data. We have these 2 different models, the CCSM model and the CFSV2 model. And we can see that the dataset name within the ClimateSERV API is CFSV2. So returning to the notebook here, in the dataset argument, I'm going to want to specify CFSV2. And I could have found that same information scrolling down to the appendix here. We can see CFSV2 stands for the NMME Climate Forecast Model version 2 data. And NMME just stands for the North American Multi-Model Ensemble, which is the name of the data. So That's our data set. Our next, or actually our first argument that we want to give is the geometry. So scrolling down to the appendix, looking for the geometry argument, which I found here, we can see that we want to feed this into Python as a two-dimensional list of ordered coordinate pairs. So what that's going to look like, if you're not familiar with lists, is just square brackets, and since it's a two-dimensional list, we're going to have nested square brackets here. And in the appendix, we can see that each one of these coordinate pairs is going to be represented by a list of longitude and latitude values. So we need to define our region of interest. So what I'm going to do is just open up the Google Earth Engine code editor to find a region of interest. But of course, you can do this any way that you so choose. So just going to the Google Earth Engine code editor, then what I'll usually do is I'm just going to pick an arbitrary region of interest for this example, and then I'm going to draw a geometry, and then I can use the inspect tool in Google Earth Engine to see what the latitude and longitude of these points are. So we can see our first longitude value is negative 91.25. So I'm just going to make a variable called lon1. I believe it was negative 91.25 or 26. And I'll make another variable called lat1, which is 39.51. So that was the point in the bottom left here, and then I'll get the other longitude and latitude from, again, using the inspect tool and clicking in the top right. So we can see that our second longitude value is going to be negative 89.63. And our second latitude value is going to be 40.42. And so I want to enter these in as a list, a two-dimensional list for our geometry argument. So I'll say lat1, or excuse me, lon1. Lat1, I believe, is the format that we want to use. Again, I'm just checking in the appendix. Yes, wants it as lon1 and lat1. The second coordinate will be the first longitude, but the second latitude, and so on and so forth until I've drawn out a polygon with these different coordinates. The last one will be lon2, but lat1. And so in this case, we gave a list of coordinate pairs that outline a square, but you can make this polygon as complex as you want. So our geometry and our data set are specified. Our next step is going to be to specify the operation type. So scrolling down to the appendix, we can see that if we want to download tabular data, we have to set operation type to be one of the following strings, either average, min, or max. And this is going to specify the spatial reducer that ClimateSERV will use to take all of the pixels within our area of interest for our data set and aggregate them to a single value for each date of acquisition. So I'm going to use the average data or argument in this case. So I will just specify average, and these are case sensitive, and you have to make sure you are spelling them correctly, otherwise ClimateSERV will give you an error when you run the actual request data method. Next, we have to specify our start and end date, and these are in month, day format, which you can see again in the appendix. So this is a forecast data set, so we're not going to use historical dates here. I want to see what the forecast is in this area of interest for the future in terms of precipitation. And this NMME data set goes up to 180 days in the future which again, I can find all this information within the encyclopedia. So I'll specify my start date as today, and I want to go a couple months in the future to see what the forecasted precipitation is in my region of interest. So for this ensemble and variable argument, these are going to be specifying the ensemble of the model that we use to forecast this data. So again, I can find out this in the appendix, what the actual codes are to enter in here. But I want to look at precipitation, and I'll just use the first ensemble in this data set. And again, I found those out from the appendix. So we've specified all of our arguments. The last thing to specify is what we want to write this, what file name we want to write this data to. So I'll just call this forecasted precip. And again, this file extension that you give is not arbitrary. So if we're requesting tabular data, we're going to enter it in as a .csv. If we are requesting the raster data, we'll enter it in as a .zip file. So everything looks good there. I'll go ahead and run that cell. And then here we are requesting the data again, but instead of the initial data request that used different arguments, we are going to specify these arguments that we just wrote out here for dataset 2, operation type 2, geometry 2, so on and so forth. So I will go ahead and run that, and we can see that it is running and it's almost complete. And then ideally, if this works, when we run ls, we will see that we have a file called forecasted precip. We can see that it worked, just as ClimateSERV predicted it would. So again, I'm just going to use that for loop to iterate through the different files, or excuse me, the different rows within the CSV, and create a nice visualization. So again, you can open this up in Google Drive and take a look at it. And then when we make our plot, we want to say, give it a nice label. And these will, of course, change depending on your data set requested and the time period of interest. In this case, the unit is in millimeters, which again, I knew from looking at the dataset encyclopedia. And I'll just say this is the NMME forecasted precipitation for southern Illinois. And there you have it. That is how to use the ClimateSERVpy package to request and visualize tabular data. So again, you want to just use this appendix to your advantage when you're specifying those arguments, and use the ClimateSERV dataset encyclopedia to figure out the units that your dataset is in, as well as the available time period and spatial range for these datasets. So if you request data that is outside the temporal range of that dataset, or outside the spatial range for that matter, ClimateSERV will run, this dataset will get written, but when you go to pull up your CSV file, you'll see that it's blank if it is outside the time or space range of that data. So you, again, want to make sure that you're requesting data, that the data you are requesting is actually available over the time period and area of interest that you are requesting it over. So that is what the encyclopedia is meant to be used for. So in the next video, we will take a look at how to do this exact same thing, but with actual raster data. So in this case, we looked at a time series, but in the future, we'll take a look at how to request raster data and visualize it within a Google Colab notebook. So that's it for this video. I hope you enjoyed, and we will see you in the next video. ClimateSERV was developed by Servir's Science Coordination Office, specifically by Ashutosh Lemay, Brent Roberts, Eric Anderson, Billy Ashmall, Githika Tundapu, Francisco Delgado, Roberto Fontanarosa, Lance Gilliland, and Alex Goberna. The curriculum materials were organized by Servir's Science Coordination Office. Individual modules were created by myself, Mickey Maganini, and Billy Ashmall. Crucial insight regarding the creation of the curriculum materials was provided by Dr. Roshanak Darvishzada. Review of the material was conducted by Severe Science Coordination Office, specifically Brent Roberts, Meryl Kruskopf, Ashutosh LeMay, Billy Ashmall, Deanna West, Katie Walker, Lauren Carey, Jacob Abramowitz, Jake Ramthen, Natalia Bermudez, Stephanie Melick, Emily Adams, Stephanie Jimenez, Vanessa Martin, Alex Goberna, Emil Sherrington, Francisco Delgado, Biplav Bhandari, and Amanda Markert. Review of the materials was also conducted by Bart Kroll and Laura Cray of ITC, the Faculty of Geo-information Science and Earth Observation at the University of Twente. The course and banner images were created by Gianluca Ambrosi of ITC.